Hi, so today what we're going to be doing is linear systems doing the elimination method using addition or subtraction. Okay, so the first thing I need to do this is I need to make sure that my equations are set up they're lined up, x above each other, y above each other, and basically my constant above each other. They're written in standard form in this case, and so then I can go ahead and line them up and start canceling things out. So in this case, I want to figure out, am I going to end up adding or subtracting these? Well, I see that 5y and negative 5y, if I add them, they'll cancel out. So I want to make sure that these guys cancel out, okay? So 5y plus negative 5y will cancel each other. So those are gone. But now I'm looking at 7x plus x, or 1x. So I have 7 plus 1, which is going to give me 8x, okay? And that's going to be equal to 18 plus negative 2. 18 plus negative 2 is the same as 18 minus 2, so that'll end up giving me 16. So I have 8x is equal to 16. Well, I do algebraic isolation, so I'm going to divide both sides by 8. And I end up with x is equal to 2. So if x is equal to 2, now what's going to happen is I'm going to plug 2 back into one of these two equations. All right, so let's say I wanted to plug it into the x minus 5y is equal to negative 2. I could do that one. All right, so that is x minus 5y is equal to negative 2. All right, so x minus 5y equaling negative 2, and if x is positive 2, then I'm going to go ahead and plug that in. All right, so now I'm looking at 2 minus 5y is equal to negative 2. Well, I'm going to subtract 2 from both sides, giving me negative 5y is now equal to negative 4. And to finalize this out, I'm going to divide both sides by negative 5. This cancels out. Now I have a positive y. And negative 4 divided by negative 5 gives me a positive 4/5. So my y value is 4/5, and my x value was 2. So we had an answer of x is 2, and y is equal to 4/5. Okay, because sometimes these answers are not whole integers. They're not integers all the time, where like it's a whole number. Sometimes they are fractions, okay? So here we go. Let's continue on to another one. If I have 4x plus 3y is equal to a positive 7, and negative 4x plus y is equal to a positive 5, we'll work through this one. Again, I'm going to figure out, do I need to add them or subtract them? And again, I made sure that my x's are lined up and my y's are lined up. In this case, I'm going to add them. When you have a situation where the signs differ, like you have a positive 4x and a negative 4x, add them together. If I subtract it, I'd end up with a 8x, and then I don't want that. So 4x plus negative 4x cancels them. I get 0x. And then from here, I'm looking at 3 plus 1. 3y plus 1y gives me 4y is equal to 7 plus 5. 7 plus 5 giving me 12. And then I ask myself, hey, 4 times something gives me 12. That number is 3, and I can isolate by dividing by 4 on both sides, and I end up with y is equal to 3. Okay, so if y equals 3 now, did that not make it? All right, so y is equal to 3. I don't know why it's not showing up here, but if y is equal to 3, there we go. All right, so if y is equal to 3, now I'm going to go ahead and I'm going to plug this in to solve for x. Okay, so I can say 4 times x, what was it? 4 times x is equal to, plus, what am I looking at? Is equal to 7, okay? So I'm starting to plug in for y in this case, and we said that y was equal to 3 right here, okay? So I'm going to replace y with 3. So now I'm looking at 4x plus 9, because it's 3 times 3, is equal to positive 7. I'm going to continue isolating. I'm going to subtract 9 on both sides, which will give me a negative 2. All right? So now I have 4x is equal to negative 2. And then we'll divide both sides by 4, because we're isolating x. Divide by 4, blah. And we end up with x is equal to, basically, negative 2 divided by 4 is going to give me a negative 1/2. That's supposed to look like a 1/2, not a 1/3. So let's clean that up. And we'll have it at negative 1/2. So x is negative 1/2, and we said that y was equal to 3. Okay, so basically my answer was negative 1/2 and 3. All right, that was my answer for that solution set. One more of these, we see if we have x plus y, that's x plus y, is equal to negative 7, and 3x plus y is equal to negative 9. All right, so to solve for this one, again, we're going to combine these, but the funny thing here is that I have a positive y and a positive y. If I added these, I'd end up with 2y. And I don't want that. I want to cancel out my y's, all right? So what I'm going to do is I'm going to subtract these. Now, if I'm subtracting 3x from x, I'm subtracting y from y, and I'm subtracting a negative 9 from a negative 7. You want to make sure that you are thinking that you are subtracting in each of these cases. You may choose to rewrite the problem applying, basically flipping the sign on each, getting a negative 3x, a negative y, and a positive 9, and then combining. You can do it that way. But I'm just going to do it as it is right now. So I'm going to be subtracting, and I'm looking at, hey, first of all, what is x minus 3x? So basically 1 minus 3 is going to give me a negative 2x. And then I have y minus y. These cancel, so I have no y. And then I have negative 7 minus a negative 9. And so if I have a negative negative, basically I'm adding. So it's basically negative 7 plus 9. Because when you subtract a negative, it's the same as adding. So negative 7 plus 9 is going to basically give me a 2. So what I'm looking at is negative 2x is equal to 2. To isolate, I'm going to divide by negative 2. Cancels out, and I end up with x is equal to 2 divided by negative 2 is negative 1. So I have a negative 1 value for x. Okay, so I have a negative 1 value for x. Now I can plug in this value of x into either of these equations. I'll go ahead and plug it into this one. All right, so we knew before that x plus y was equal to, I think it was negative 7. Yes, it was. Okay, so x plus y is equal to negative 7. And so my value for x that we set over here was negative 1. X was equal to negative 1, and so I'll plug it in over here. So basically, I'm looking at negative 1 plus y equals negative 7. So I'm going to algebra this. I do inverse operation, so I'm going to add 1 to both sides. And that gives me y is equal to negative 7 plus 1 is negative 6. So my y value is negative 6. And we had x value at negative 1. So my answers were negative 1 and negative 6. And this is the way that we use the elimination method on either adding or subtracting when solving linear systems. All right, I hope you have a great night and take care. Thanks. Peace.